In this video, we're talking about particle motion on a line. So I'm going to go through a couple different examples and then have you finish the packet on your own. This first one questions 1 and 2 refer to the graph above. A bug begins to crawl up a vertical wire at time t equals 0. The velocity v of the bug at time t between 0 and 8 is given by the function whose graph is shown above. So notice this is time. This is velocity. That means that velocity, this is a graph of the velocity, which means this is a graph of the derivative. So it says, at what value of t does the bug change direction? Well, remember, a graph of velocity is very similar to making a number line of our velocity or a number line of our derivative. And remember, critical points are when the derivative is 0, so we would put 6 on the number line, and our derivative is positive and then negative. So at what value of t does the particle change direction? Would be at time 6, because the particle starts moving right and then starts moving left. What's the total distance the bug traveled from time 0 to time 8? Well, remember, we can find change in position by looking at area under the curve. This area is positive, so we're moving to the right. This area is below the x-axis, so we're moving to the left. But because it says total distance, we're going to make both of these positive. If we were supposed to find the change in position, we would this top half would be positive and the bottom triangle would be negative. So when I would do total distance, I look at this and I see two triangles and a rectangle here and then a triangle here. So I would have 1/2 base times height plus the rectangle, 2 times 3, length times width, plus another triangle, 1/2 base times height, plus, because it's total distance, plus the bottom triangle, which is base of 2 and height of 1. So my total distance traveled looks like it's 3 plus 6 plus 3 plus 1. So it looks like 13. Letter B. That's the total distance the bug traveled. Now, that doesn't tell us where he's located, that just told us how many steps he took. Number 3 says, a particle moves along the x-axis, so this position at any time t is given by x of t. Remember, in x of t, we can think of this as s of t. For what value of t is the velocity of the particle 0? Well, if this is position, we find the velocity by taking the derivative of position. So the velocity would be 2t minus 6. And we want to know, when is the velocity of the particle 0? So it's not time 0, it's when is velocity equal to 0. So we set this equation equal to 0, and we would get at time 3. Number 4, this is a trick question. It says the maximum acceleration attained on the interval from 0 to 3 by the particle whose velocity is given by v of t is. Okay, we want to maximize acceleration. So how do we find a max and a min? To find mins and maxes, we look at the derivative. So we actually have to analyze the derivative of acceleration to find the maximum. We're given the velocity, so first we'll find acceleration, which is the derivative of velocity. But then to find the maximum, we have to analyze the derivative of acceleration, set that equal to 0, and find our critical points. So at time 1. And we're given this interval from 0 to 3. We have to test this because 1 might not be the max, 1 might be the min. So between 0 and 1, use 0.5. If we put 0.5 back into our derivative, we're going to get 3 minus 6, which is a negative. Then if we put 2 in for t, we're going to get a positive. So that makes 1 a min. That makes 0 and 3 the max. So we need to actually find the acceleration at time 0 and the acceleration at time max to find the true max. Well, the acceleration at 0 has a value of 12, and the acceleration at 3 has a value of, we have to substitute 3 in for t. So we get 27 minus 18 plus 12, which is 21. So the maximum acceleration, acceleration of this particle is 21. It's a trick question because a lot of times people will take the acceleration, this function, and set it equal to 0. But because we wanted the maximum acceleration, we have to analyze the derivative of acceleration. On to the next page, you are going to include problem 5 and 6 as part of your homework. Those are both no calculator problems. Number 7, the data for the acceleration of a car from 0 to 7 seconds are given in the table above. If the velocity at time t equals 0 is 11 feet per second, this is the initial velocity. So v of 0 is equal to 11. The approximate value of the velocity at time 6, computed using a left-hand Riemann sum with 3 subintervals of equal length is. So LRAM3, the first thing we look at is all of our subintervals are the same length. So we don't have to do separate rectangles. We can take 2, because they're 2 units between it, and we're using the left hand. So if we take this, the left-hand value would be 5. If we take this, the left-hand value would be 2, and here it would be 8. So we would have 2 times 5 plus 2 plus 8. So LRAM is going to be 30. Now, because we want to find V of 6, remember this just finds the change in position approximately. We also have to add this 11. So it's really 11 plus 30, which would be 41 feet per second. 8 and 9 are going to be counted as part of your homework, and they are calculator problems. So make sure you use the calculator. And also 10, 11, and 12 are also part of your homework, and they are also calculator. Practice using the store button if that comes up. Practice putting it in for Y1 and typing that out. Okay, and then I am doing another problem with calculator for homework. This problem in the video, this is technically a no calculator problem, and you are doing. Okay, it says rocket A has a positive velocity after being launched upward with an initial height of 0 feet at time 0 seconds. The velocity of the rocket is recorded for selected values of t over the time interval from 0 to 80 seconds as shown in the table above. Part A, find the average acceleration of the rocket A over the time interval from 0 to 80 seconds. Indicate units of measure. So part A, we're supposed to find average acceleration. So that word average should mean to you old-fashioned slope. And what's units for acceleration? Well, in this problem, velocity is feet per second, so acceleration should be feet per second squared. So we want to have units of feet over second squared. So we need to use change in velocity over change in time. Isn't this going to be feet over seconds divided by seconds, which gives us our feet per second squared? So we need to do change in V over change in T. And since it's over the time interval from 0 to 80, we're going to do V of 80 minus V of 0 over 80 minus 0. And this comes straight from the table. 49 minus 5 over 80 gives us 44 over 80, which reduces to 11 over 20. Don't forget to put your units on your answer, feet per second squared. Letter B says, using correct units, explain the meaning of the integral from 10 to 70 of V of t in terms of the rocket's flight. Use a midpoint Riemann sum with 3 subintervals of equal length to approximate the integral. Okay, so the integral from 10 to 70 of V of t dt if we were to find the antiderivative of velocity, aren't we at position from 10 to 70? So wouldn't this be s of 70 minus s of 10, because it's the, you take the antiderivative and then evaluate top minus bottom? So this represents change in position. So s of 70 minus s of 10 is really talking about the change in position. And again, that we don't have those numbers in the table. Our table is velocity. I'm just showing you this to show you what we're talking about. So this integral represents the change in position of the rocket over the time interval 10 to 70 in feet. I have to put units in there. So then it said to use a Riemann sum, a midpoint Riemann sum with 3 subintervals of equal length. So M ram 3. And it's equal subinterval length from 10 to 70. So if we're using midpoint, it's going to be 10 to 30. So that has a subinterval length of 20. And the midpoint would be using 22. Then from 20 to 40, we would use, from 30 to 50, we would use 35. And then from 50 to 70, we would use 44. And remember, this is no calculator. 22 plus 35 plus 44 gives me 57, 97, 101. 101 times 20, if you have to, go over here and do this, is 20 feet. So the midpoint to approximate the integral is about 2,020 feet. Okay, so part C says rocket B is launched upward with an acceleration a of t, feet per second per second. At times t equals 0, the initial height of the rocket is 0 feet. The initial velocity is 2 feet per second. Which of the two rockets is traveling faster at time 80? So this is really saying which rocket, rocket A or rocket B, has a greater speed at time 80. Okay, so for rocket A, we have the table, and rocket A has a speed of 49. We're given the acceleration of rocket B. So to find the velocity, we would need to take, which remember, velocity is speed. We just have to know that it's giving direction as well. It could be negative. So because the velocity is the antiderivative of acceleration, to find the velocity of rocket B, we're going to take the integral of the acceleration function. So the integral function, the acceleration function is 3 divided by t plus 1 to the 1/2, which I would change to 3 times t plus 1 to the negative 1/2. So we have to take the antiderivative. Remember, 3 is a constant, so I'll keep that. Keep my quantity and add 1 to it, which would be positive 1/2. But then remember, we have to times by 2/1, the reciprocal. And then we put plus c. This gives us an equation for the velocity. So our velocity for rocket B is 6 square roots of t plus 1 plus c. And remember, it says velocity at time 0 is 2 feet per second. So velocity is 2 when time is 0. So we get 2 is equal to 6 plus c, so c is -4. So the velocity equation for rocket B is 6 square roots of t plus 1 minus 4. So we want to know which has a greater speed at time 80. So we need to find the velocity of this rocket at time 80, which is 6 square roots of 81 minus 4, which is 6 times 9 minus 4, which 6 times 9, hopefully you know that, is 54, minus 4, which is 50. So rocket B has a speed of 50 feet per second. So we need to make sure we answer the question, which of the two rockets is traveling at time 80 seconds? Explain your answer. So rocket B is traveling faster at time 80 since 50 is greater than 49. Okay, so there's the equation or the work for particle motion. Remember, this was no calculator. Your job is to go back and finish all of those other ones. Make sure you wrote down which ones you're allowed to use calculator on. Best of luck.